Good morning. Hope everyone's doing well. So we have our last set of notes that we're going to be taking, and this will finish us up on hypothesis testing. So we're going to look at that today and look at, are we able to identify what test is appropriate? And then we'll do some review and plan next Wednesday to have some sort of test. And on Tuesday, I'll do a Google Meet so that we can go over any questions you have. And then we're really going to start hard into reviewing for the AP exam. So our last test is called the Matched Pairs T-Test. Now, when is this used? Because we went through one proportion, two proportion for categorical. We did one sample and two sample. And so now we're going to talk about, okay, what is this matched pairs and when is it used? All right, so when we've been looking at two proportion or two sample tests, we have to do the independent groups condition. Now, a lot of you are forgetting that condition, but it is one that we're supposed to be doing, and a lot of times we do just have to assume that whatever's happening in group A is independent of what happens with group B. But when we know that they're not independent, that it's the same person or the same thing or one thing affects the other, then what do? And so here's where we can look at two groups that are not independent and still be able to test them. A lot of times, if you look at examples of how you collect your data, if it is with a survey, they'll use the term matching. I'm looking at it here and here, but for the same person, collecting data at different times on the same person or something like that. In an experiment, it's usually if you have blocking, that type of thing. So just some things to look for in specific questions. Now, here's the thing, is that this is really just a one sample t-test for the differences in the two groups. And we already know how to do a one sample t-test, hopefully. All right, so how do we write our hypothesis? Because that's how we start every time. All right, so this one's a little bit easier. We don't have to pick a number to put in there when you do a matched pairs t-test. Okay, so it's going to be mu sub d, d meaning difference, okay, equals 0. That's the null. So the difference is 0 is really what that's saying when we're looking at the pairs. And then your alternative is that it could be less than 0 or greater than 0 or not equal to 0 like we always look at. Okay, so then we have our conditions for our sample. So always randomization 10%. This is looking at both samples, but it's usually the same group that's not independent, but making sure both samples that we're taking are randomization 10%. And then we have our nearly normal. Now, with the nearly normal, when they give you the actual data, you have to check it with a graph. If they give you the graph, then you don't have to worry about it, or if they don't tell you, and you have to assume it. But if you are given the data, you do the nearly normal, you check that distribution of the differences. So it's just one histogram or stem and leaf plot or whatever you want to use. Dot plot could work. stem and leaf, again, I said if you're typing it, but I really highly recommend that you all write it out and upload your answers. But write neatly, or make sure you're able to type math if you're going to type it on there, and learn how to, type an equation. So we need to start practicing that also. So next week I'll do a video more about typing math to help some of you that want to do it that way. All right, so those are your 3 conditions. There's no independent groups because they're not independent. Then we have our statement. Okay, so because the conditions are met, will you perform a match pairs t-test using the student's t-model. Now, here's the thing. The match pairs t-test is really just a one sample t-test. So to do your statistics, you find your t-score basically like you do for one sample. So it's going to be your sample minus of your mean of your differences minus 0 over the standard deviation of your differences over the square root of n. Now, obviously, when you subtract 0, it's just that number, but we write it out that way to show that's what we're doing. The degrees of freedom, which some of you all have been forgetting on this for one sample, is n minus 1. And then to get the t-score and the p-value, you do just like you would in your calculator for a one sample t-test, so stat test 2. And then your conclusion, same as all the others. All right, so today I am going to, instead of just posting the example, I'm going to do a second video with that just to make sure we're not missing anything.